Hi guys, I hope you're good since last video. Agentic workflows. How do you actually do that? How does our IDs evolve to have a picture of how we are going to make an agentic application from scratch? What do I need to visualize? In this video, we are going through the planning phase and through process. We will go through the ID evolution and what I need to put in visual form to be able to code it easily. The whole purpose is the development of understanding. This is the first video of some few ones about agentic app creation, from ID to the app running, and the reality of what works or not. Open your terminal. No, this time you won't need. Just listen and let's get started. Okay, so you're gonna see it's very interesting. We're gonna go through 8 different diagrams and you'll be able to see how the ID has evolved and the architecture of the application also. So that's how it has started. I started with a ID agent working with GitHub upstream. So the idea here was to have GitHub as an upstream repository, to have a local repository with human agents, different agents working on different branches, specific branches for each agent. So separate folder on microservice, and after they'll be pushing to the upstream. Here there would be a pull request and there would be a human check. And here the local human would be able to or git clone or push directly to the main branch of the repository, having full hands on it. So that was the idea of what I wanted to do initially. So I wanted to do it in an easy way using a long chain and Python, but we'll be challenging ourselves and making everything in Rust, because we haven't seen it made in Rust. So we're just gonna create our ID from that. So here, just to simplify the way, so this diagram has changed. There's no more anymore GitHub. We're working fully locally with an upstream, having a main branch and having different branches linked to their counterpart agent. PR review. This is the agent here working on the pull requests. What I'm doing here is simulating a pull request, but using an agent to make those pull requests. We have the local, it's still local, but every single agent has their own branch. That's what it says here. One local repository. It will evolve after, but just stick to this ID for the moment. So here there is no main branch. There is only future branches. Okay, we set as an upstream. So here I put upstream, but actually everything is going to be pulled from this repo to that one. So the main repo sets the lower repo as an upstream, so it can fetch changes from it to simulate pull requests. So this should have been normally main instead of upstream. After here, I just added some different plan, how I would use it. Here we use git fetch and review the changes for each future branches linked to their counterpart upstream. The main branch will be merging those PR, so to the main. If OK or not, use an intermediary file to communicate which branch dev agent, with the branch dev agent, which will action the PR review agent when it has again made the changes. So I just here put the idea that we might need a communication file in between those agents. When PR review agent has validated the communicated, it communicates to the main branch agent, which will merge the corresponding PR branch changes to main. So that's why I wanted to use those communication files in between the agents so that they can take action. After, another agent will pull the main branch from the application to run the files of the repository. That was the idea. It wasn't 100% clear yet, but I started here. So you need to start somewhere, start drawing something. After here we have something a little bit more organized. Here I have all the different commands that I would use. I've just put here example of main agent, how to initialize it and how to use it in the app. So the setup of those repositories. And here we have a cleaner, more simplified and easy to understand diagram. So merge agent, main repo. We have the future branches still with the PR agent, which is going to take care of it. It's just going to git pull. It's going to pull from agent folders. They all have now, they're not all in the same repository, having different branches. Now they all have their own folder. They're all separate Git repositories, so own folders per agent. At this time, we can instruct each agent to add files, to commit, and there will be only one branch, their own branch, which makes life easy. After here in the writing, we needed to put more organization in how we gonna work, communicate, write, and read. So for each agent, we have a human agent, we have a main agent, the pull request agent, and the different SREs agent. I have planned 3 SREs agents. So for the human, work, create agents prompts, create spec files, create tools for each agents, create agent-specific spec files. Communication, read reports, update request files. The main agent, work, merge work. Communication, notify human, write to file, report on work, communicate file to PR agent, read from file, human file with requests, agent work specific spec file, and it can read also PR agent communication file. The PR agent will pull the work, will communicate notifying the main agent and the SRE agent if there is any issue. In terms of writing, it's going to write to a communication file for human and another for the agent. Reading is going to read SRE agent spec file, the main agent communication file, and the SRE agent communication file. For the different SRE agents, you will have the same work, commit work, communication with PR agent to pull, just telling him that they are done with their work, and that the PR agent can pull the work. They're going to write SRE agent communication file, and they're going to read its specific spec file on the PR agent communication file. After here, I did some notes for the files. Human request file, prompt with keyword, special keyword to stop, an agent specific spec file. So main, PR, and R series will have those spec files. Main agent report file, communication file, main to human is the report, so no need communication file. So here I started to think that I might not need all those communication files, main to PR, PR to main, maybe to not use 3 files, write the same file with parsing. If too complicated, do not do it. PR agent, 2 SREs, 3 different files, it starts to accumulate. We start having too many files. SREs, PR agent, 2 different files. Tools, Discord notification human tool. So I put it first, but the ID came at the end almost of the project. I had the watchdogs ID also for human request file changes, which starts the agent workflow. Watchdogs on the repo files. So whenever any file in any repository is modified, starts communication with the agent, notifies human, who will decide what to do through request file change, which will be picked up by the watchdog and start the agent. We have the Git tools, the commit for the SREs, the pull for the PR agent, and the merge for the main agent. Write communication files, read communication and spec files. So that's the tools that we might need. And we might need also, this is notify flows, don't need tools, as the branch would have a conditional to go to the agent notification receiver node or just agentic for. So here I'm starting to change my ID. But what stays is that there are tools. The files might disappear. The communication way might change, but I put it in the next here diagram. We still have those watchdogs, and we want to see how the process is going to work. So we start the agents. Start the agents using the process, the watchdog, human request. That file has changed. The watchdog is triggered. The trigger is going to start the agentic workflow. Okay, so here there is an arrow with all the files on the top. Human request prompt with keyword to stop. Okay, that's what the human provides and have access to. The report at the end, or the Discord notification. So you see I'm still hesitating between file and Discord. Agent specific files, for sure the human have access to it. And here the communication between the agent, this is just internal to the agent. So the main agent is going to communicate with the PR agent, which is going to be communicating with SRE agents, which each have their own repositories, folders. They all have access to a toolbox with Discord tool and all the Git of the tools that I told you before, commit, pull, the tools also to read the files and so on. So this is the third diagram, and here are all the communications, files, spec, human requests, and the reports, the end reports. So after having done that, I thought that I might need to use different nodes representing a huge agent, which will have sub-agents. So here we're going to go like that. The idea here is to have a human world. In the human world, it's a full agentic workflow. We have a main agent world, which is a full agentic workflow, meaning with the sub-agents. The PR agent, same, is a full agentic workflow, and same for the SRE agents. Each of those worlds, so the different agentic worlds, will have tools. Here, for example, for the SREs, commit tool, read file tool, write files tool. They have access to the specific agent, the spec files of the agent. the agent have access to the repository. Here I just put repository like that, but those are their own repositories for the SREs, for example. So depending on which agent we are on, for example, the PR agent will be on the main repository. And same here, has tools. And here my idea was to use the SRE agentic word as a tool for the PR agent. Instead of using files for communication, you can use it as a tool directly. So we have different agentic words, and in each agentic word, you can use an agent as a tool. Okay, so I put here an example tool list that starts other agent workflows. So here, same for the PR agent, it has the tools, it has access to the repository, which will be the main repository, and the spec files. And the main agent has all the tools, but this is also where we're going to try to end the application. So all flows end here, success or error with a Discord notifier. Discord notifier goes to Discord, and that's the end. Okay, so the human starts everything. Okay, so we have just decided to not use watchdogs or keyword to stop, but just a flow that would notify success or error to Discord, and then human would be able to send a new request or just be satisfied with the output. Okay, so that's what the human does. He gets the Discord notification at the end, he just reads it, and after it goes to the main repository and decide what it's going to do. It's going to start the agentic workflow by sending this request. Okay, and the human check on the repo, and he can git clone it to do the last verifications. If it is not satisfactory, he can send a new request. So now that we have an idea of how the architecture would be, it has evolved a bit. I needed to focus more and have something about the access and how I'm going to organize the folders in the Rust workspace. So here we have user, Git access, app access, Discord access. So the user have access to Discord, where I'm going to set a special category for agent report, category for agent notification to user. Okay. And after the human have access to the files, to the application. After, when we are inside the application, main.rs, which has a run function, engine, and a .env secret storage file. So that's where we're gonna put all the secrets and all the environment variables. The application have access to the user request file, so there will be now just one file. The user request one has access to the core of the application. The core folder will have all the channels and threads, the states, the parsers, so all the side functions also creates, LLM calls, the prompts, the structure outputs, means the schema. We will have another folder dedicated only to the agents, all separate different agents modules, uses only core for logic. And we have the repository. Human have access also to the repository, the Git flow already set up with upstream. Okay, so the communication basically is human to prompt analyzer to the main agent to the SRE agents. And after here we have an intercommunication between PR agent and the SRE agent, and the PR agent to the main to the human. That's why everything stops at the main. So the prerequisites for this stage, I need to have a prompt for each agent saved to file and will be injected with LLM call using format macro. How transmission is done between agents. The end of one agent would update the command state, and the flow would start the parent agent that could check the state and see which tool to call until the job is done. So here I'm still having the idea of using states. First agent reading user prompt, with the user prompt, calls LLM with content of the file and prompt talking about what is the context of the project and what structure output we want. Structure output, which tasks, for which agent. Discard validation of action done and work transmitted to main agent, which is a tool mandatory to use. The main agent reads the received message from the first agent by pulling state accordingly. So here I'm still having the idea of using states, have SRE agent as tool, and calls those in a loop so that we are sure that it can call both if needed in the requirements. Okay, requirements might be for several different agents. We have a loop running. The loop running can call different tools, so different agents, and send to those their respective tasks. Have a merging tool access and have a disk notifier tool for each actions. So here, as you can see, I said the main agent is going to contact directly the SRE agents. So it has changed a bit from what I've said here. Where is it? Here, when we say that the main agent have access to the SRE agent, but no, here human has a prompt analyzer is going to analyze tasks for who, for which agent, and it's going to directly talk to the agent, tell him to start working. And after the flow is going to go this way. So I've eliminated this one here. So the main agent will be called only once at the end. So I'm trying to simplify while I'm actually progressing in my ideation of the application. So the SRE agent, it has tools to read files of the infrastructure, to make diffs and check. That's the ideal one. There won't be all those tools in my example. Have a tool to see Git history. Have a tool like kubectl to get infra and application, to check on those. Have a tool to make commits. Have a tool to send disk notification. Save outcome to state. Have a state to update for work done, and another to report on work. Here I'm still using states. I'm still declaring that disk notification should be sent for every single agent, but at the end of the disk notification, I've decided to just put those at the end of the workflow and to exit, to fail fast, to have an error message whenever something happens in the application, and to stop the flow. Peer agents have tools, different ones, one to pull the SRE agent work, to check the infrastructure for validation. I didn't put the validation in the app, but in the great idea, that's what I wanted to do initially. Have tool to check Git history, and have a tool or a condition to forward requirements to SRE agents or main agents. So this is like a backward communication with SRE agents in terms of whenever there is any issue. Okay, so we're almost at the end, but here is the most important part. Response request schema. So before starting to code, you need to go to the provider or the API you want to work with. You need to study the documentation, and you need to know what response you expect, what request the API wants you to, the requirement to respect the requests accepted by the application, the API. So we're going to start with the response, and we're going to check on the objects. We start entering a little bit on the coding part, but here you can start creating your structs. LLM response, I'm going to just deserialize here as we're working on the response. We have choices. Response choices is a vector, and we have the object string. The objects need string. After here, all the different comments that I put is specific to the API that I'm using. I'm using Cerebras for this project. Okay, so let's see here. We have the LLM response. We follow the structure of the response and we extract what we need from it. We need the response choices. So we get the vector response choices. We have another object, response choices. Finish reasons, string. Message, response message. In the response message, we get the content and the role. So that's what we need from any response from the LLM. So from that, we will be able to actually even check if there is any tool call and everything. Here are the requests. In the requests, I started by just creating a big struct, the huge struct called agent. And this struct agent will have a role, agent role. We're going to explore each every time. It's an enum, request agent analyzer, main agent, peer agent, SRE1, SRE2 agent. So I narrow down to 2 agents, SREs instead of 3. After here, we have the message. We have the prompt, vect &string. Here I can read this. For human request analyzer agent, for example, human structured output agent, dot agent. That's how I'm going to be able to reach it. Human structured output, tasks. But at least we are free to add any key pairs. So structured output, I create a struct called the struct out, and we're going to go for the struct out. Struct out, we have the different ones, human, main, PR agent, SRE1 and SRE2. And we have the schemas for each. So I have created that in the term of ID. But this one here, I found a way to not make it that complicated and to use the schemas directly, creating those constants. And after here, we can go in the schema, just a little focus on it. Just a little focus on it, so we have different fields, schema, file type, and after here we have the properties, which is an hash map string schema fields. So let's go to the schema field type so that you can understand. This one is just an enum, string, bool, or U64. Okay? That's what I'm going to use for the types of those schema fields. And after here we have required. You have to check the Cerebras. You need this one here. And after extra properties, schema field type also. Okay? So we go back here to the huge agent. After we have the task state, I just put it back here like that. The task state completion. It's an enum. Is it done? Is it processing? Is there any error? And this is where all tools will be set, the model settings. Okay, so that's what the agent has, and we're going to go into the model settings. That's the leg, the long leg that we had here. And the model settings, we have what you know when you call any LLM, the name, max completion, temperature, the message, it's an hash map, it's a vec, you see here, content hello, hash map, inside we have the string, content, string, hello. We follow the structure. The tool choice tool, and here we have none, auto, or required. Same here. This is to comply with Cerebras requirements for the API. After here we have the tools. I use just option because we can have tools, and we can also not have any tool, so that we can use the same struct for tool call and non-tool calls. And here we have the type at the end is always function. So let's go for tools so that we can see those functions. The tool is a vector of functions. The functions have a type. So this is always function, as we said. This is how Cerebras payload asks us to define it. And function details. Function has a name, description, and it has parameters. The parameters of the function: type of string, of type string, properties, and required. The properties, the function parameter properties, expression, so it's inside the dictionary, so I'll just separate it like that. Function parameter, properties, expression, and after here we have type, string, and the description. So we get the parameter description like that. Okay, so you can start creating your struct like that. Doesn't mean it's going to be like that 100% at the end, or you're going to use all the fields, but at least you have a plan prepared, you have read the documentation, and you have a good knowledge of the schema of the application. So looping using channels to perform agentic work autonomously. So I had an issue after that. It was how I can mimic those long chain agentic workflows that I have done in Python. I really like the way we had the different nodes and how we could call another node just by using its name. So here is the diagram for that. How we have adapted it in Rust. Request analyzer called the transmitter. Okay, so we get the output, send message with the next node address. Next node address here, I'm using just the name of it. So transmitter always sends to the dispatcher. The dispatcher from the previous output gets the node address, and when I get the node address, that's how I can direct it to the next node. Okay, so you see here the flow. And after here, inside the node is one big agent, having inside sub-agent. And when it's done at the end, it's gonna send this output to the transmitter, get output, send message with the next node. So here we get the name of it. When it comes back to the dispatcher will be able to dispatch to the right node. And the next agent is gonna work, and so on. So this is the loop. We have an error exit, an error and an exit also. But I have integrated it in another way. Error, I have decided to fail fast, so it can fail anywhere here. So we can exit because of an error anywhere in the app. While here, exit, we're going to exit at the last node. So the last node won't have any transmitter. It will just stop here, okay? So that's for the issue of having a dispatcher here. That's how I'm using the REST channels. And here, SRE agent chaining API call structure. So here I'm showing you what is inside one node, for example, the mini sub-agent, and how I'm going to handle the API calls and the structure output. So here we have one mini agent, which is going to be handling the file reading. It's going to read the file. It's going to choose a tool to read the file, get the content of it, and get a structured output of it. Structured output, the next agent is going to use it to write the file. It has a special prompt, so it knows what to do, what to modify. It gets a structured output. Structured output goes to the commit the work, and after you get a structured output, he's going to create a report on his work and everything that has been done before. We get a structured output of it, and this is how it's going to provide to its transmitter the address. Here, let's say the address is a PR agent, and the transmitter is going to call the dispatcher, and the dispatcher is going to dispatch it to the PR agent. And the PR agent is going to be also a full agentic workflow like that, specific to itself, having its own different sub-agents. Okay. We have now a visual picture of how the AI REST agentic application will work internally. If you have watched the video fully, you have a great idea of how the app is intended to work in a very high level. Some changes might occur, but this is an overall view of it. In the next video, we are going through some other explanations and demonstrations. I will see which ones. I have set up different models that we can use to test which one is the less dumb. I focus always on what could eventually run locally, so no GPT-5 or any Claude, Sonnet and friends. I believe that AI shouldn't be trusted and should be given very deterministic and narrow windows of move to keep control and limited tasks to reach satisfactory performance consistency. So having small local models could work with that type of way of processing. I use here Cerebras, but you could use Grok or any local model. But use the model that you could eventually have running locally if using any APIs like Cerebras or Grok. Stay tuned for the next video. We stay on the subject and focus on other part of it. Okay, let's stop here. Hope that you liked this video. Please like and subscribe, and see you next time.